Alright, time for another draftphysics.com. Debatephysics.com also. But, hey, wait, we have a change. Yes, we found someone to debate, finally. Yeah, it only cost 1,000,000 Qcoin. Yeah, I talked him into Qcoin. You know, I only have to pay the $1,000,000 when a quantum computer adds 2 plus 2 faster than a, like 1975 Radio Shack calculator. So I think I'm safe, but we'll see. Anyway, it's Veritasium. Yeah, it's one of the highest viewed YouTube science presenters on Earth. Yeah. So anyway, so yeah, his frame rate really sucks. But hopefully, everything will work out okay in terms of the audio content, and so I can ask him a few questions. I did ask him to preview some of my arguments, so I shouldn't have to go into all the details, and we should be able to have a conversation. So, hello, Veritasium.
Yes, it's me. The one and only
Veritasium.
I like to be called,
Veritasium.
uh, not like Veritasium. It's one of those things like, I like and such.
Okay, well, I'll try to remember that. And anyway, so Bartosium, uh, one of the subjects is the Eddington experiment. And for the viewers, this involves, this idea that light is bent by gravity and that you can see it or detect it or measure it. Oops, pause. Okay, should be back. Anyway, so you can detect this bending of the light through different mechanisms, but the most direct with visible light is to just look at an object behind another object. So if some object is very far away and it's behind some other object, you'll be able to detect this deflection of the light. The light, you won't see it in the right place, and the object will appear to be in the wrong place. And it's sort of like just, you can look at fish underwater from the surface at an angle, and you'll see the fish in the wrong place. Or you can put a pencil in a glass jar, and there's lots of ways to see effects that are similar, but they're not being deflected by gravity, they're being deflected by some other object. So it creates an optical illusion because the light is actually turned in its direction because the gravitational force pulls on it. Now, Einstein's theory is that the gravitational bending is twice as much as any material object. Even though, theoretically, why would that be? That the photons are supposed to be aren't supposed to have any material substance. So how the hell are they bent? Anyway, this experiment's never been repeated successfully, and yet it made Einstein famous. And I'd argue they still haven't got any really good evidence that this bending happens outside of atmospheres, outside of, if you look through the sun's corona, well, scatter will make sure that some light gets to you. So light goes everywhere, so the bending will be viewed from every location because the light is physically bent like in a glass jar. So anyway, so the fact that it's never been done from space, where there's 400 times better viewing resolution, seems to me a glaring example of really bad science. What do you think?
Well, I actually did repeat this experiment. I didn't do it from space. I did it with a cardboard box on a beach, I think. Yeah, so I think I repeated the experiment successfully. So I think others probably have too since I did it. Other people always do what I do because I'm a leader, and other people, follow because, like, I'm a leader and such.
Well, actually, I think the experiment you did was a duplicate of the Young double slit experiment with the cardboard box. And, yeah, that's, just, it's okay. I mean, if you want to do experiments as they did them in the 1800s, that's all right. I just think that's a little short of great physics. But anyway, it's really not the same subject. And so, the real point is that NASA has, and the CIA and all kinds of stuff. They have all kinds of cameras up in space, and with 400 times better resolution, it means you really don't need much technology up there, and you don't need an eclipse. So, you can do the experiment anytime, and it only takes about 10 minutes to do your little time lapse, photography. And they've apparently, we're supposed to believe that they've never even tried the experiment. It's the experiment that made Einstein famous. It's kind of an important experiment. It's kind of an important concept. The fact that light is bent twice as much, that something moving the speed of light, a force, is bent by another force. This is a real challenge to all the other established premises in physics. It's sort of a physical fact that magnetism doesn't affect magnetism, and I can't point two laser beams at each other and force the light to bang into each other. So how does this force bend another force?
Well, in one of my other videos, I prove that gravity's not a force. So it really isn't a force bending a force. Yes, it's moving the speed of light, but that doesn't mean it's a force. The fact that it's moving the same speed as all the other stuff we call a force doesn't mean it's a force. Of course, and all that.
Well, even if I concede that gravity is not a force, don't you think this is an experiment that should be repeated, that maybe you should try it, or you should suggest it to somebody, since you're really important, that you should point out that this is sort of a really important thing. We all should be able to see this in visible light. We shouldn't pretend that experiments where they're actually shooting light through the huge atmosphere of the sun, the corona, that those experiments are actually the same experiment when they're not the same experiment. Shouldn't there be some concession? This is a really important experiment, and it's kind of crazy that with the 400 times better resolution and the billions of dollars worth of telescopes up there, that this should be something done by science. You won't concede that point?
What do you mean by conceding a point? I don't understand that concept. You mean you're expecting me to say something that would be like innovative or different than my dogmatic agenda as Veritasium? I don't understand. I'm here to be Veritasium. I'm not here to, be somebody else. So Veritasium knows that light is bent. And so why would I need NASA to do an experiment when I already know the answer? We all know the answer. Miki Ayakakui knows the answer. All the other people, who have fancy names or interesting names, they all know that light is bent. So why do we need to do it again?
Well, Eddington stated in his own journal, that he wouldn't stake his life on the results because the, quality of the images he's got were so bad. So on top of it being 400 times less resolution, he didn't have good weather and he didn't get great pictures. And it's sort of, like I said, I think it's kind of something I want to see. Before I'm going to believe, I want to see it. And NASA has the capacity to do it in a way that is just undeniable, and we can all see it, like seeing the little blue ball in space kind of thing. And I think we should see it.
Oh, so you're one of those seeing is believing kind of people. See, we see things as scientists, as smart people. We see things as mathematical concepts. So we reduce everything into little squiggly lines, and then we just add the squiggles together and come up with a new squiggle. And the squiggle is basically a representation of the truth. And so we don't really worry about actually having to see anything because, we can draw it like on a little piece of paper and a little tiny, like even on a matchbook or something, like a girl's phone number. We could just draw it on there, And it's already obvious and simple because we've reduced it to its essence and mathematically figured it out. And you can see this. I mean, if you need to see something, you can see all these like gravitational lensing images that are all over the space. Like Hubble telescope has taken zillions of pictures of all these little smiley faces and things in space that shouldn't be there if the space wasn't all bented and crookedy. Well, no offense, but I think you're evading my question. But to deal with the lensing issue, I mean, all of those images, these math, you're saying the math is, something you depend on and something you like to see the world reduced to little stick figures. I personally don't find that very compelling as evidence just because it's like you square velocities, and you're just like, I'm going 10 miles an hour squared. I don't think I am. But anyway, that's another subject. We'll get to that. Uh, you know, it's obvious that you can look at the images and they are all broken and misfigured. I mean, Albert Einstein said you'd never see an Einstein ring because it would have to be so thin. There's such a small amount of space in which a gravity lens actually sends the light to the same focus that it would be a terribly tiny, thin thing, and there'd be so few photons that you'd never see one. So how can people claim something is doing an Einstein ring or a partial Einstein ring when a partial one isn't even theoretically a possibility? I mean, it doesn't make much sense to mathematically. I don't think. And so you're saying all mathematics is wrong. So even though we've proven that 2 plus 2 equals 4, you're saying that like some kind of flat earther that all mathematics is impossible and can never get the right answer and it completely can't work and that it's all wrong and every single bit of it's wrong. Is that what you're saying? No, what I'm saying is okay, yes, this is really complex math. I mean, you have to figure out lots of different angles and positions and viewing angles, and so this optics stuff can get kind of complicated. But what I'm saying is I think if you do the math rigorously, that is carefully and thoughtfully, that there's no way there's a mathematical solution that would produce the effects that are in the images. The images can't be made by some kind of consistent mathematical application. That a gravity lens isn't a viewing lens. It's actually bends the light you need bent more less, and it bends the light you need bent less more. So it's almost an inverse lens. So it can't produce good images. I mean, it can't produce the images that are being claimed to be produced. That the math can't do that. Well, I think you're just being ignorant. I mean, I think you know that there's stuff called dark matter that clearly is a really great mathematical symbol. It's like it's like the Joker in a deck of cards. It's just like this amazing thing that you can make it into anything almost. If you put it in the deck and you play poker or something, you can have this wild card that can be anything. And you can end up having 5 aces or something. It's amazing. And dark matter is like this wonderful thing that just shows up and it makes all the squiggly lines less incompatible, and it just reduces all of these problems and just gets rid of all of them because it just, it creates this magical amount of gravity to fix all of those mathematical problems. So if there's something wrong with the image, you just sit there and say, well, there was some dark matter right over there, and the problem is solved. So again, you're saying there's a problem when there's no problem. I mean, we have a very good proof. It's all, the Joker wouldn't be in the deck if the other cards didn't think it was a good idea. You gotta understand, right? I mean, the Joker, the King and the Queen and the other cards would say, hey, you can't be in this deck if you're not compatible. So of course it must be compatible with the other physics. Come on, you've got to be able to understand this. All right. Well, look, could I get as a minimum concession that it would be better, right, to have NASA take
the regular lensing style image, to like point the camera at Jupiter, because Jupiter has a very clean atmosphere. There's a very sharp edge to its atmosphere, and there's not a lot of energy coming out of Jupiter. Electrons and protons and gamma rays and all that kind of stuff. So you can take a really clean picture, and so the gravity might be half of what you would get at the edge of the sun's corona. Outside of the sun, a whole full radius away from the center of the sun, a full 2 radiuses. So instead of 80 meters per second gravity, you have 40 meters per second gravity, but you have 400 times better resolution. So it's a huge advantage in doing the experiment. And wouldn't you want there to be this piece of evidence in the evidence pool? It doesn't take any effort really, except for you people, scientists, to say they should do the experiment. They'll do it if you say do it. That's just a fact. So if you say, hey, why haven't they repeated this experiment? Then they'll feel obligated to repeat it. So I'm just suggesting that you have the power really to say whether this experiment ever gets repeated or not. And that maybe you should take it seriously as something that needs to be done.
Well, you're not understanding my job as a dogmatist at all. I am a science presenter. That means that I present the book of science, and I do it in a way that doesn't confuse people, so they know that our God is God. I don't like to use that metaphor, but that's really what it's about. It's about keeping people on track. And the track is that we really need to do this science stuff where we just keep making more and more science. If we run out of science, then it's sort of like running out of farmland or something. All the people will starve unless we can make more and more food to feed more and more people and kind of thing. And information, you have to make more and more information. And you can't make more information if you live in a universe where you don't have any dark matter, and you don't have any quantum qubity things, and you don't have all that fun stuff. You can't expand your intellectual property, you see. And so you're just not getting my agenda at all. My agenda is not to get, is not to sit there and say, oh, look, they haven't done anything to validate any of this science they're teaching. No, my job is to keep the ball rolling. Keep the bandwagon well oiled and rolling along. That's really my job. That's what I get paid to do, pretty much, entirely. All right, so you won't concede that it would be a good idea, or it'd be nice, just be nice, that we had this extra piece of scientific evidence for the phenomenon. That, it'd be nice to have these actually good images. We could probably even have, videotape of, stars moving because of gravitational bending of light. You don't think it's worth the trouble? Well, yeah, exactly. See, I already know it's true. I already have the videotape in my head. I am completely convinced, and then I have all of my colleagues completely agree. So, yeah, there's really not a problem. So why should I be, emphasizing or worrying about, your problem, frankly? I can't solve all the other people's problems, right? It's not really my job. I'd like to be able to fix everything for everybody and make all, if they have flat feet, I'd like to make their feet rounder and all that kind of crap. But, it's really not my job. I have enough to do just to do my propagandizing for the cause of scientific expansion. And that's my job, is to expand the information universe, because information is everything. It's in a hologram and such around the sun. Well, it's around any kind of gravitational body, technically. Why wouldn't, if black holes can store information, why can't anything store information, really? Anyway, that's my own personal theory. I don't really want to get into that. So, yeah. exactly. I'm sorry. I just don't understand your need for evidence. I mean, that's just not something I worry too much about. This evidence stuff.
Well, I guess I sort of have to concede your point that yes, needing evidence is something of a personal problem I have, and but it does make conversation, on the subjects of science kind of difficult if there isn't some agreement that the fun part of it, the fun part of a trial is the actual evidence and actually arguing the evidence. So if I were to use that analogy of lawyers defending positions, that evidence is kind of a fun thing to argue about, and so we'll see where we can go with these other subjects. So we'll call this a part one, and we'll see how we do on the other subjects. But I'll concede, if you're not that interested in evidence, then yes, the Eddington experiment doesn't really matter. So, point taken. All right. So, this has been the first part of a series of videos that will be the continuation of this interview with Veritasium. I mean, Veritasium. Yes. Okay, so till the next time. And such. This has been at draftphysics.com. Debatephysics.com also. But as you can see, even when you have a debater, the debating can be very, very difficult.